Do you guys have answers for this first one up here? Solubility? Alright, so Jay says NaCl. Okay. Give me another one that's soluble. That doesn't have NAs or CLs in it.
Potassium nitrate.
Okay. KNO3. Alright, another one. What was that, Jose? That'll work. You can always say any one of the group 1 metals from lithium down to francium and in anything else. Any anion, because they'll always be soluble. How about some stuff that's insoluble?
Calcium carbonate.
Okay. That's what seashells are made out of, so yeah, they're not soluble. Another one? That's okay, except you need to give me more than just lead. If you say lead iodide, I don't know if you mean this or this. Lead 2 iodide? Sure. That would be lead 4 iodide. Okay. Silver bromide? That'd be perfect. AGBR. Alright. Alrighty. How about the names for these things here? And the next one? Okay. The next one?
Magnesium nitrate.
And the last one? Do we need to do any balancing? Yeah, what do we need to do?
We need to add a 2 on front before the silver bromide.
Okay. That will balance out our bromides.
And then 2 silver nitrate.
And then 2 silver nitrate. And that will balance out the silvers and the nitrates. Okay. What about states?
They all 4 solid.
No. Aqueous. So this whole kind of problem, do you remember what the topic was in the notes? Oh, the topic was reactions in water. And what we're trying to show here is this guy here is in a test tube already, and this guy here is in a test tube already. So they're already aqueous, and then I'm going to mix them together. They're only aqueous if they're soluble though. Okay, so this guy is, and so is this one, and so is this one. But this one's a solid. Are we okay with that? Why is the first one aqueous? Say again? Yeah, I'm asking, how do you know that?
Because of the solubility rules.
Which one?
The chlorides, bromides, and iodides are soluble.
Okay. Is there a magnesium rule? Nope. So then you just go off the bromide rule. How do we know the next one's soluble?
It's the nitrates.
So the nitrates are soluble, but what about the silver? The silver's insoluble,
But the nitrate rule's higher.
but the nitrate rule's higher on the list. So it wins. And the next one? We already said the nitrates are soluble and we don't have a magnesium rule. And then the last one, why is that a solid?
Because the silver's insoluble. The bromide rule's below it on the list.
So there are rules for both of them, but the silver rule supersedes because it's higher on the list, and so it's insoluble. What does it mean when something's actually aqueous? It's already been taken apart, right? So when we write the full ionic equation, we take anybody who's aqueous and separate them out. So Mg aqueous plus 2 bromides with a -1 charge. Plus 2 silvers. Plus 2 nitrates. Plus a magnesium. Plus 2 nitrates. Plus 2 silver bromides. What hasn't changed at all from one side of the arrow to the next?
Hasn't changed.
Hasn't changed.
Magnesium and the nitrate.
The magnesium is exactly the same. And what else?
Nitrates.
The nitrates are exactly the same. So those two ions are called what? Spectators. So when I go to write my net ionic equation, I leave them out. They don't get included. So then I'll just have the 2 silvers and the 2 bromides, making myself 2 silver bromides. That's the only thing that really happened in this reaction. So as you guys were turning in the homework, I noticed there weren't a lot of you who did this problem. So let's go ahead and go through it. Do we know what the formula is for propane? C3H8. I don't expect you to know that off the top of your head, but you could have looked it up pretty easily. And it's a combustion reaction, so what's also a reactant? Oxygen. And then anytime I take a hydrocarbon, a compound that's just made of hydrogens and carbons, or a compound that's just made of hydrogens, carbons, and oxygens, and I burn it, my products are always what?
CO2 and water.
The same products you get with you guys when you breathe, when you have respiration. So I need to balance this out, and let's put states up first. Propane's a gas, oxygen's a gas, CO2's a gas. I'll just write down gas for water. And balancing, what do you want to do?
3 CO2s.
Okay, if I put a 3 here, they're balanced. What else? 4 water molecules does what for me? Balances out my hydrogen, okay? And then O's. 4, 5, 6, 7, 8, 10, so 5. Okay. That looks good. All right, so what we want to do now is, if I started out with 25 grams here, how much water am I going to make? Making a statement like this assumes something. What does it assume?
That you have enough oxygen to react with all 25 grams of propane.
Yeah, all 25 grams of propane are going to react because I have plenty of oxygen. All right, so I don't need to worry about how much oxygen I have because when you get a question like this, they're assuming you have plenty of that. All right, so I'm going to start off with 25 grams of propane. Do you guys have a mass for propane? I got 36. Like 44 or something or other.
I got
There's going to be some decimal places with that. I'm going to write down 44. But if you guys are doing this on a test or on homework or something, you need all the decimal places. From the 12.011 for the carbons and 1.00795 for the hydrogens. This first step in the railroad track does what for us? So that's the mass of what I have. I really don't care about the mass. What do I care about?
The number of molecules.
Yeah. I want to know how many I have. And this first step converts from grams to moles. And that, in doing so, you just counted them. Are you okay with that? Okay, so now I know how many I have. Now I need to know how many I need. So this next step is the number that I need. So I'm going to go moles propane into moles of what? O2? No. What am I looking for? I'm looking for water. Okay, so what numbers do I put in front of the moles? A 1 here and a 4 here. Here's the 1, and there's the 4. So if I didn't balance this equation, I'd be off by a factor of 4, right? So that's the first thing you got to do when you see an equation is balance the thing out. Okay, so great. I know how many water molecules I need. Am I good to go? Can I walk into the lab and start counting them? No. I need another mass because I can't count them. So moles, H2O, and then grams, H2O. I'm going to write 18 because I'm sick. But it would be like 18 point something or other, right? 16 for the oxygen and 2 for the hydrogens. All right. Let's see what this works out to be. 25 divided by 44 times 4 times 18. I got 40.9. So to answer this question, if I started off with 25 grams of propane and as much oxygen as I need, I'd end up with 40.9 grams of water molecules.
That's 41 grams because of the
Yeah, I would. I'd write 41.